Okay, so I hope that you're well rested because I think we're going to take you on a pretty intense journey today. You'll be with us the whole day, but luckily we have a number of presenters, so it should be interesting. You're not just going to listen to me drone on the whole day. So we have people from Cornell and the Boyce Thompson Institute. So I don't know, there were a few of our participants that were from outside the area. I'm not sure if they're in right now, but just for anyone that's unaware, the Boyce Thompson Institute is a Cornell affiliate. So we're actually located on the campus, same campus as Cornell University. So we work pretty closely together. So that's actually where I work. I'm the director of our computational biology center there. And then Jing Zhang works with me as well, and so does Adrian Powell. Adrian also works with Lucas Mueller, who is faculty at the Boyce Thompson Institute. And then we have Andrew Nelson and Fei Wei Li, who are both faculty members at BTI, and I think they have co-appointments at Cornell as well. That's how things tend to work. And then we also have Jacob Landis, who is a lecturer and research associate, I believe, with Chelsea Speck. And then he also helps us out a lot too at the Computational Biology Center, which we call BCBC. So if you hear me say that, that's the BTI Computational Biology Center. Okay, so that's who you're going to be hearing from today. And Jing will be available to help too. So if at any point you get stuck, just feel free to open up the Zoom chat and send a message out either to everyone or directly to any of the speakers, assuming they're not speaking, or Jing. So ideally, if all goes well, you'll be with us from 9 until around 5:15 this evening. And we're going to do a lot of hands-on stuff, mainly focused around genome assembly, annotating genomes. So annotating is predicting genes that are in genome assemblies. And then we're going to have a bit on how you would do some downstream analyses with your results. So maybe some population genetics analyses or some phylogenomics. So that will be the last thing we look at today. And before everyone gets tired and is ready to end for the day, I just wanted to acknowledge right off from the get-go some people that were really instrumental in making this happen. So Cyverse, especially Ritu, Amanda, Edwin, and everyone on the Atmosphere team, which we'll be using heavily today, and also Eric Lyons. And BTI for funding this, and also NSF, which has provided a lot of the funding for Cyverse and their infrastructure. We're hoping you have a bit of background on some things, because otherwise you might find yourself a little bit lost, which is okay. I tend to get lost too, so it's probably going to happen at some point today. But if you have some command line skills, things are probably going to go a lot smoother for you on Unix or Linux. So today we'll be using Ubuntu, which is a flavor, they call it, of Linux. We're also going to do a little bit of R scripting. You're not really going to do much programming on your own. These things will be provided for you, but if you have some programming experience, it'll help you understand the R scripts and the shell scripts that we're going to use to run some of the pipelines. Hopefully you've all listened to Adrian's email and you've made a Cyverse account. And if you made the Cyverse account in time, then you should automatically, I believe, have an Atmosphere instance set up for you. So if you didn't do that before, maybe about 5 o'clock Eastern Standard Time yesterday, 5 p.m., you might not have access to Atmosphere. So unfortunately, you might just have to sit and watch. Or if you have terminal, you can try to do some of the stuff on your own computer, but you'd have to move the data sets over and it could be a little bit complicated. But if you're a power user, go for it. You also need a Koji account, which I believe is still a separate thing. You're going to do some things on Koji later on today with Andrew. There's lots of nice tools there. So Koji stands for Comparative Genomics, to give you an idea of what that's all about. And then there's some things that are nice to have, but you certainly don't have to have them. So CyberDeck can be nice to move files around. And I'm going to be using Atom today, and GitHub Desktop can be nice as well. But if you don't have those, it's no big deal. You'll be able to do what you need to do today. And here's our agenda. So as I said, I hope you have some energy stored up because it's going to be a lot of stuff. And I have to say, there's going to be some things that we kind of gloss over because anyone that knows anything about genome assembly and the annotation realizes that it's not really something you generally do in a day. So we have some short example data sets that we'll be using. And then we also have some intermediate files that we've generated ahead of time for some of the runs. Some of the tools that we use in these analyses can run for quite a bit of time and can take quite a bit of resources. So some of them we're going to cheat and just give them to you. But hopefully there's transparency in everything we do. So even the things that you don't do yourself, you can go back to the scripts and see how those things were generated. All right, so, and we do have a couple breaks built in, and we hope to end at 5:15 today. So try to keep on track. I think this is my last slide. Now 2 more slides, and then I'll pass it off to Adrian. So everything, well, that's a lie. I don't think quite everything is here yet, but it will be before the relevant section. So if you go to GitHub, you can find the materials for what we're going to work through today in this repository. And the data files are all on Cyverse, and Adrian, I believe, is also going to show you how to mount an NFS share that contains this data, and then you can copy it onto the virtual machines that you're going to be using. And yeah, just how to access Atmosphere, and I think Adrian will go over that. And yeah, so basically, some of the things we want to cover today is why assemble a genome? Aren't there already genomes out there? Why do you need to do that? Well, in a lot of cases, the one that you want isn't available. No one sequenced that one yet, or maybe the assembly isn't very good. Maybe there's no close relative. So, you need to venture out on your own and figure out how to do this. And you really want to keep in mind, and Fei Wei will go into a lot more detail about this, but I've run into people sometimes that just think, oh, just sequence a genome and assemble it and it's no big deal. But no, it is a big deal unless you're doing something really small like Arabidopsis. You definitely want to have some idea about the size of the genome, of the organism that you're sequencing, the ploidy. So if it's like a tetraploid or something like that, a hexaploid, things get really complicated in plants, especially, very quickly. And, if you have a really large genome and a small budget, how are you actually going to get the data you need? Because if you have a large genome, you have to generate more sequence and you need more resources. So yeah, I think I'll leave that there. And as I said, Fei Wei will tell you a bit more details on that. I think that's it.